In this section, we're going to cover more about graphing quadratic functions. Graphing quadratic functions of the form f of x equals ax squared plus bx plus c can be somewhat overwhelming if you don't put them in standard form. So in exercise 1, for each quadratic function, we'll need to do the following. 1. Write the function in the form f of x equals ax minus h squared plus k. Find the vertex and the axis of symmetry, and then graph the function. Here is the first function to transform and graph. We have x squared minus 6x plus 5. We need to rewrite it so that it has the form given in standard form. And then we need to find the vertex and axis of symmetry and graph it. So my first step will be to rewrite this as x squared minus 6x, and then I'm going to leave a blank space and add 5. Now this is going to be very similar to completing the square, but before we had two sides of the equation to work with. In this case, we have to keep everything on one side of the equal sign, and so we're going to incorporate a little bit of creativity when we do this. The first thing I need to do is find what number added or subtracted from x squared minus 6x would give me a perfect square trinomial. We can do this by calculating 1/2 of b, which is -6, and that gives me -3. Then I take that -3 and I square it, and that gives me 9. If I add that 9 to the function, I have to somehow make up for it, because legally I can't just throw plus 9 into a function and say, oh yeah, it's the same thing. It is no longer the same thing, unless I also subtract it over on the side. So adding 9 and subtracting 9 to the same side of the function is a little bit of a trick because it makes it work out better, but we haven't actually changed the value of that function. It looks different, but the value remains the same. So now my f of x is equal to x squared minus 6x plus 9, and then off on the side we have this plus 5 minus 9. We're going to just leave that alone for now and refactor the x squared minus 6x plus 9. It's now going to be x minus 3 quantity squared, and then I'm going to drop down this 5 minus 9 simplified. That'll give me a -4. So I have f of x equals x minus 3 quantity squared minus 4. This function is opening upwards. Its vertex is at 3, -4, and the axis of symmetry is x equals 3. So we can now draw all of this. At 3, I have an axis of symmetry. My function opens upwards with a vertex of 3, -4. And now I just count over 1 up 1, over 2 up 4, and then I create that symmetry to the left as well. And then I connect the dots with a smooth parabolic shape. This is the function x squared minus 6x plus 5, but now in standard form. Now we're going to just work out the rest of these. I'm going to leave the last one for you to work out on your own, so I'll pause the video and then you can check your work. In this next exercise, we have f of x equals 2x squared minus 8x plus 3. We will rewrite this. Where I group the terms with x separate from the constant term 3. Then I will factor out the 2. That gives me an x squared minus 4x. The number inside I need to identify to make this a perfect square trinomial inside the parentheses. This has to be a perfect square trinomial for me to be able to write it as a binomial squared. So I'm going to take my 1/2 of b b happens to be -4, and that gives me -2. -2 squared equals +4, and so I'll add +4 inside. This gives me a perfect square trinomial in the highlighted area here, but you have to remember one more detail. This 2 out front is representing a factor that we pulled out of the grouping in parentheses. So technically, if we were to distribute that 2 back in, we would have 2x squared minus 8x plus 8. So I can't just add 2 times 4 without undoing that addition, meaning I also have to subtract 8. But remember, that is making up for adding 8 inside parentheses. You could also think of this as subtracting 2 times 4 because we just added 2 times 4 on the inside. That's a very important part that you have to keep track of. Now let's go back and rewrite this as 2 times x minus 2. Because the 2 squared will give you the 4, and we don't forget the square on the outside, and then we need to combine 3 minus 8, which is simply -5. This is the form of the standard parabola or quadratic, and now we can easily graph it. My axis of symmetry is at x equals 2. My vertex is at 2, -5, and my function is opening upwards. Now we can graph it. We have a vertex at 2, -5. We have an axis of symmetry at 2. We know it's opening upwards, and so we just create our parabola. But there is one additional little piece of information that we have to remember. You would agree that a standard parabola is over 1 up 1 over 2 up 4, but in this case we also have to double that because of the 2 out front. Remember, a scalar in front of the function vertically stretches the function. So if it was a 1, now it's a 2. If it was a 4, now it's an 8. So our function has been scaled vertically by a multiple of 2. It's still symmetric, but now it is vertically stretched. So it is increasing in the range faster in the same domain distance. And remember, that is because of the 2 out front. Now let's take a look at the last exercise here. G of x equals negative 3x squared plus 5x minus 2. Go ahead and pause the video and see if you can do this next one on your own. Welcome back. We're going to look at negative 3x squared plus 5x minus 2. We need to put it in standard form, so I'm going to factor out a negative 3. I'm also going to group the negative 2 off to the side. When I divide out a negative 3, or factor it out front, I have to make up for that by putting a 3 in the denominator in the middle term. So I'll have an x squared minus 5/3 x, and then there's this blank spot for the value that will make this a perfect square trinomial, and then the minus 2 on the outside. Now remember, we have to find a value that will make the stuff in parentheses a perfect square trinomial. So I'll take 1/2 of negative 5/3, which gives me negative 5/6. Then I have to square negative 5/6, which gives me a positive 25/36. Now I need to include that inside the trinomial grouping. So I'm adding 25/36. But if I add that value inside my grouping, I have to make up for it by subtracting that from the outside. Now don't forget, it's not just subtract 25/36, because if I were to multiply this negative 3 back in, it's actually subtracting that term. So we have to add it on the outside, and we can't forget to multiply it by 3. So trace through the signs. If we multiply a negative 3 in to a positive 25/36, we will get a negative value out. That means that we have to add it to the outside. Now I'm going to rewrite this as a perfect square trinomial as a binomial squared. So I have x minus 5/6 squared, and then a negative 2 plus 3 times 25/36. I'm just going to rewrite this as, remember, if you multiply a 3 through, the 3 would reduce, and so you'll have 25/12. So I'm going to rewrite this negative 2 as negative 24/12 plus 25/12 minus 24/12. That combines to be positive 1/12. And then we just drop down the other part. Negative 3 times x minus 5/6 squared plus 1/12. So my function is now ready for analysis. I know that it's in a downward facing parabola. I know that my axis of symmetry is about x equals 5/6. I know that my vertex is at 5/6, comma 1/12, and I can scale it by 3. So now I can draw this. I find my axis of symmetry, x equals 5/6, which is just slightly left of 1. My vertex is at 5/6, 1/12. And I can now draw this parabola. Since it's opening downwards, I go over 1, down 1, but instead of down 1, it's scaled by 3, so I'll go down 3. And then to the left 2 and down 4, but 4 multiplied by 3 is 12. So it'll be somewhere down here. And then the symmetry will bring that to the other side as well. So this is a very sharp parabola, and it's kind of hard to draw freehand. So here I've gone ahead and graphed this parabola so it's a little bit easier to see. Hopefully this has helped you with graphing quadratics and quadratic functions and identifying the different parts of a quadratic so it's easier to graph.